So I'll just give a little bit of idea. Perfect. So students, today we are going to have a very, very interesting innovation and creativity lecture where we are going to see how the creative process works, right? And how you can build ideas. So those are very, very important aspects in the creative process. Because idea is all about, coming up with completely novel, out of the box and out of the, and delighting the people for whom you're building these type of, ideas and solving problems. So let me go now, to this very interesting presentation where I'm calling it stage gate process of, creativity, where we can just see how we can actually look at the process and take things forward. Yeah. Okay. So here we go. So we will start with our process and we will see role of engineering is both inventive and exploitative for product innovation in the industry. And that becomes a very, very important, a hallmark for us. And from that hallmark, we're just saying that innovation is not something totally new, but rather a new mode of something already existing. So, so you're just showing, maybe you're doing the same function in a very innovative and better way. You're actually using some other material to do the same job. And I've got great examples on this. For example, I was just telling you that I built this palki for Vaishno Devi, and they were using galvanized iron pipes, which are easily available, the water lines, but the pipes were very heavy and they were not long lasting. So we just converted that by using stainless steel pipes and then made it lightweight and easy to carry and long lasting. But then came this very interesting issue of sustainable practices. I said, why stainless steel? Can't I use cane? And then we used cane, and that took us longer to design. Students, I must tell you this, any challenging assignment takes us much, much longer, but it is much, much more innovative and beneficial to the people at large. So those are the challenges which we, will address. So that next palki I made was made out of cane. And when I made out of cane, it became more lighter by 10 more kilos. So from 54, we came down to 34. From 34, we came down to 24. And now, we're planning to implement that, palki there, which is made out of natural materials and will be as long lasting as the stainless steel. So that's the beauty of design, creativity and innovation. So here we are, doing every time trying to do something which is more comfortable for the people, more useful for the community at large, and of course, more, good for the environment at large. So today, I got this very interesting assignment from my own class, Master of Design students at IDC School of Design. And we said, let us look at spoons as an expression of creativity and innovation. In fact, students, please remember, I did talk about this whole big conference and exhibition which the Italian embassy had put up in Delhi, from spoon to car. And I did mention that in my first class, where the aspects of the spoon is as complex as the aspects of car. So when I said spoons, my students were not very excited. They felt, what is there in a spoon, right? You use that every day. But spoon in a new avatar, spoon in a new way of use, spoon in a new material, to learn creativity is the best sort of tool. So we took spoons as our as a product for this whole course, and then of course we had multiple students forming having each sort of topic. For each student had to choose a topic, and we're not supposed to do any. This is not a design project, so it was a project on exploration and creativity. So you're not supposed to even look at the other types of spoons in the market in the same domain. So you just supposed to be just selecting a function and then taking it forward. So we had a design brief, we had an ideation stage, then we had clustering of ideas. Very important, students. When you have one idea, you have to come up with, when you have 50 ideas, you can actually build 3 wonderful concepts. You'll see all that how it happened. Because you're building upon ideas, so your creativity goes up multiple times. Similarly, concept generation, where you build 3 concepts and then go to models. And then again, I always repeat that from sketching, when you go to models, your creativity jumps by again 3 to 4 times. So mock-up models, we say. So engineers have to learn this mock-up model. activity. I keep mentioning this a lot that I was in Japan at the Tokyo University, and I've been visiting this lab, mechanical engineering lab, where the professor was working on the suspension of the railway carriage, the next generation suspension, so that the railway carriage of the high-speed trains are very, very comfortable. And to my, surprise and delight, the professor was actually making physical models of the suspension in thermocol to experience the design, so that he can be very creative, he can quickly build the product in a nice way. And of course, he has all the calculations and all the design details in his computer and CAD models. But making it physically in thermocol and understanding very quickly what is there, how the structure will come, how the things will sit, was really, really wonderful for me to see. And that is where we engineers have to go if we have to get creative and get innovative. And of course, then comes the final prototyping, where you use actual material. You have done a lot of exploratory models, and then you come to the final prototype. So here we go now to our to our spoons project, where, remember, in my first lesson I did talk about creative analogies, and it basically helps you to get diverse sort of diverse ideas and diverse options by using analogies, and see how we can go forward in those situations. And we use the synectics creative technique over here, but basically to solve the problems. And we actually, the ideas generated and examining how they related back to the original problem. That's very important. We build a lot of ideas. Then once you build a lot of ideas, you relate it back to your problem and see how they work. And then, for example, the topic chosen by this student, Sarang, who currently heads the design department at Crompton Greaves, and has come up with fabulous projects. One of his best projects, and this I don't remember the year, but this project had happened some 4 to 5 years back, and he went into Crompton Greaves and took this wonderful analogy of using a seagull. He was going to Elephanta Caves for a visit to the caves in Bombay, and he was sitting in this nice boat, and he was watching these wonderful seagulls effortlessly gliding in the sky. And he said, I'm a fan designer. Why can't I make my fan wings as effortless and as noiseless as as these seagulls? And then he worked relentlessly for the next 1 year to build this fan, which actually uses much less power and which actually uses much less sound but gives you more air. So that's the beauty of bionics. Again, a very, very large area of work. So let me take you forward in my presentation with Sarang, and this is Sarang's sort of spoon. So I had to tell you where he started. So, for example, in the idea generation stage, you of course can take multitude of ideas generated from very, very different analogies. It could be anything you like to anything around you. Remember I was telling you, the symbolic analogy, the direct analogy, the fantasy analogy, of course, and of course the personal analogy. And then of course, those are the things which he took. And actually for some of the indirect analogies, like, he used also the cycle for an indirect analogy for designing a spoon. Isn't it foxing? You're designing a spoon and you're considering a cycle as an analogy. That's the beauty. I can't even, get my head onto how a bicycle can be taken to create an analogy. And you'll see all that coming up in a very interesting way. So here are the first stage, students, is to build a lot of ideas by quick sketching. You take analogies and you sketch. That's very important. So here you are seeing a lot of these analogies where, like for example, playful analogy. These are analogies of toys. Your analogies from, various other, equipment for the garden. So you have those garden shovels. You take the analogy from a shovel. Look at this analogy, the front of a shovel. Then you have analogies where, you look at, multiple sort of wheels, and, and of course also the plaything, which the student has shown over here. So you take multiple analogies and you take multiple ideas, and those are all the ideas which are coming in. And of course, the ideas are then clustered into groups. So I have a lot of, just because of paucity of time, I'm showing you only a few ideas, but we made nearly 150 ideas. And out of those 150 ideas, you need to now cluster them to build concepts. So here we are going with the clustering of ideas. So what happens is, this is a very, very important technique of clustering. So when you have to cluster, you need to have some sort of visual or functional or material or any one parameter which you should consider for clustering. So that's a very, very important journey. So here, for example, look at this first cluster. They have a very similar type of long handle. They have the holding area, the spout area is a little deeper. So they all automatically clustered as cluster 1. And look at this cluster 2. This cluster 2 has some fancy handles. The handle is very innovatively, changed over here. Hence, all these became the, different handle cluster, right? And look at the third one. In the third one, for example, you have some very interesting features in the spout and the handle. So this become a feature-ridden group. So you basically can cluster, the ideas as groups, and this is not a very, very critical, बहुत जैसे hard rule नहीं होता है. You don't need to have very hard rules, but you cluster by card sorting, so that you feel, oh, it can go to this group, you can go. For example, this particular thing could easily go into that group, for example. It doesn't matter that much. But I felt that it should be in group 3. This forms a group, so I put it in this group. So this is a very, very important technique of ideation where you go into groups and you take things forward. And for example, then we go to our next cluster, representative. So once you build a cluster, then you take a cluster representative where you say which one of this is a very, very novel idea for a small kid. Remember the spoon for small kid, what was the age group I said? 2 to 3 years old. 2 to 6 years old, if I'm not mistaken. So that, cluster representative will come from the first concept. So now look at the magic. So this is one spoon which comes as the representative and the combination of all the other ideas. So now once you take the representation, students, this is a very interesting journey. See, you took the representation and then you added all the other spoon details in that representative, and the representative became like this. So you're building upon your ideas. So this is the, spoon where you have this, which is a mix of all your ideas from your representative. So just imagine, this spoon is not possible to be sketched or designed without the process. This comes because you have, catapulted, you have actually multiplied your creative quotient multiple times to make that spoon. So now we have the next one. The cluster 2, right? So here, for example, this is the representative, and see what's happening. You add all the other aspects from the multiple ideas, and when you add all the aspects, look at what happens with your spoon. So this is the concept 2. Look at how different each concept is. Right? It's fabulous. It's a very good technique, and I'm so glad that I'm able to showcase this. And a lot of research has happened in these techniques in IT Chicago, in my own Professor Atwankar from IDC IIT Bombay, where we call affinity mapping of ideas, putting them together to grow the ideas into powerful concepts. Right? So let us look at the third one now, which is the third cluster. So from the third cluster, you chose one cluster representative. There it is. And from the cluster representative now, you actually are building, taking all the ideas from all these things and putting up, and building your sort of main concept. And this is the concept 3. So when you are building upon your own ideas, the idea becomes very, very powerful. And it then turns into a concept. And then all your 3 concepts will actually compete with each other, right? So now comes the next stage, students. Remember I was telling you from the sketches, now we are going to the next stage where we're talking about building models. So here I used another very, very nice technique. I told the students, the spoon doesn't need to be of the same size, number 1. Remember our creative analogy, make the strange familiar, make the familiar strange, or make the small big, make the big small. Very simple. That professor was doing the railway carriage in Japan, Tokyo University, was making the big small in thermocol. And he was exploring. He was exploring how the parts will be sitting, how the springs will be going through, how the hydraulics will work, how the bolts will be put, and in a small scale thermocol. The large became small for him. And here the small spoon is becoming large for us. Look at his hand size and the spoon size. And I use one more technique. I told the students that you can only use wire to depict your spoon. You use three materials. The first material you use is the wire. You all know, students, when we use wire, we only can do outlines, right? So you're actually building, and you have a constraint now, and creativity becomes much, much more enhanced with constraints. And the next one was, of course, the planar, the paper sheet. You use paper or aluminum sheet to build your spoon. Look at this wonderful thing the student has done. Because this planar surface is not sort of rigid, he made a little sort of ridge over there so that it's possible. So now this ridge is a new thought in a spoon design. Look at this jetting out. Look at how this spout has been arranged. So everything is coming in a very different way. Similarly, look at this, the aluminium, even the spout is not well, but just by building these models, we can actually, really understand much, much better how things move. And from here, then we had the third, important aspect, which is making out of, thick material, which is 3D form. So that's the one making. In fact, it was supposed to be solid wood, but in this case, the student made it really flat. He was supposed to use 3D form to use thermocol or wood to make it. I'll show you another example where we use the 3D, form to work out. And of course, I did talk about, make the strange familiar and the familiar strange as a creative journey. And from there, we were, here it is, the third. I don't know why, we jumped the queue there. But here, for example, we have exploratory model in high density polystyrene foam. Thermocol, the standard packaging material which you have. And look at how the spoon has shaped now. The same spoon, you saw the wire, you saw the paper, metal and wood, and then you now are seeing a 3D form over here. And look at the angles and look at the radiuses, look at all the details of how it works. And actually this makes you, feel and, the spoon in a very different way. And from here, we have this very interesting assignment. He made his friend enact with the spoon, right? They also made a paper ball. This boy, Sarang, is very, very good at origami. Look at that bowl. I just remember, he makes origami animals. He conducts workshops in airports on building origami, animals with paper. And after seeing that, bowl which he made in paper, I just wanted to mention to you this wonderful, images he creates. But look at that spoon now of, how how he's enacting and, feeling for it, just to see what the spoon looks like and feels like. And then, of course, we have the concept 2, the wire model, the paper plane model, same type of exploration, and of course the solid exploration in thermocol, the 3D form. So we are doing the linear, the planar, and the form and the 3D. And here we go, and again the enacting and feeling and how the angle, orientation. Very interesting. This spoon has to be directed, right? It's got, it's one-way traffic. You have to really aim, to sort of have in your mouth, and children love it. And and your food is not going here and there. Look at each spoon has its own, own advantages and of course disadvantages. So that's the beauty of multiple concepts. You build multiple concepts and each concept will have its own advantages and disadvantages. Then you weigh all those advantages, disadvantages and consider your final concept. We'll show you how that also happens. So here we are, the third model in wire. Isn't it wonderful to see how the the wire is giving you those multiple places for the children to play? These are the places where the children can put their fingers and play and hold the handle. And of course, then we have the paper model, which is also next to it. And then we have, the next wonderful, model in thermocol in two different materials. And look at this interesting thing. The 3D solid model doesn't even have a cavity for the spoon. It's not needed. It's a mock-up model. It is for action. I can imagine the cavity there because that's not very difficult to do. But if I do the cavity, maybe the thermocol will break. So it doesn't matter at all how we take things forward. Yes, so that's the wonderful aspect of how you take these multiple material challenges to come up with innovative shapes. And we have the next important component of how you work out on all the details. And again, you go back to sketching. Oh, how will the hole for the finger work? How will the transition between this surface and this surface happen? How will the bend work? And multiple things, and detailing and the sketching is a very important task. And out of all those sketchings, again, you finalize because the student did choose as that age group of children are very playful. So he chose this third concept as his main concept because it was playful. Children can use it in different locations and different ways, and he used this as his main main design. And he further refined the model, and now you can see the model he's used is a PU foam, a little bit more refined, better foam. And this is the foam model. And look at how you can hold this spoon in multiple ways. And from this, you can see his friend playing with the spoon and, poking with it, turning it. And children like to play. Children like to work with the spoon in their own way. And that was the paramount reason why, Sarang chose this, concept. And of course, then he said, oh, it looks very complex. Can I make it simplistic? So one more refinement. And then with testing with the people, I said, oh no, this refinement is making it more serious. So go back. So making multiple iterations is a very, very important aspect again. And, after those multiple iterations, you actually, do an acting with the product. And then, you actually, do evaluation of which one would you choose. As I told you that, concept 3 was chosen. And some of the parameters of evaluation were very straight. This was a straightforward innovation course. So here the spoon had to be very innovative. It had to have innovative form. Form and aesthetics play a very vital role for a designer. It had to be, using material in a very innovative way. New materials will have to be come in. It had to have an innovative interaction. Today, it's a world of interaction. Interaction with the kid had to be phenomenally innovative, and innovation in the manufacturing process too. If I use the same manufacturing process, there's not much fun. So we need to innovate on the manufacturing, and of course, there should be some technology which needs to be, coming in. So these are the parameters which we gave so that they can choose the out-of-the-box ideas for their projects. And finally, the selected concept was taken forward, and students studied various aspects of the processes. For example, the innovative form was good. It was playful. You saw how they actually, the student played with the form, and how it was so easy to handle and so wonderful for anybody to hold. And at the innovative interaction, you saw more deeper level of interaction with the user. The user was involved in it. I'm very sorry that we didn't have kids to play with, but ideally we should have taken the thermocol models to kids and shown them. But our students enacted like kids and worked on it. And of course, we tried to use thermoset plastic material as food grade, hygienic, and then we also specified the type of weight needed. And of course, manufacturing process could be, ranging from, very interesting, very large processes, like rotomolding was not the right process, as the student has mentioned, but the processes can be, where you could use very simple techniques like, high pressure injection molding using air-assisted method, which is novel at that time. And of course, you have to understand different materials and things like that. So this is the final prototype the student made, which is exactly like the intention. So there we go. So it's a lovely journey for us to see this spoon, and I'm very, very happy, students, to tell you that this spoon also won a design award later on, and Sarang had presented it. We also made a research paper on this spoon. It is called the stage gate process of innovation as a research paper. I'll share that paper also with you. And it's again had all those wonderful interactions, and it had that type of feel as a children's spoon, and of course it had a very playful, interactive sort of feel to it, as well as to activity to it. And so each of my student did different spoons in these type of genres. So I'll quickly show you the other journey from various, various spoons, where I won't, go in depth into each of the activities, but I'll quickly show you. So here it is. We now will show you the other, spoons from the students, and this is the whole journey which I want to share with you, where, for example, how the sort of various students worked on various spoons. So here we have the soup spoon. The student chose a spoon for building, for drinking soup, and look at all the ideas he built. Then he made cluster representatives, multiple concepts. There's a thin handle spoon. Again, cluster representative for that. Look at those small wings which are coming. They're supposed to be resting on the soup bowl. And of course, he made some thick handle spoon cluster. And in this cluster, he has this as his representative. And then, this is the concept 3 for him. And look at the wonderful exploratory models. Right? They can be really funky. They can be strange. Using wire. He used, wire and solid form, but doesn't matter. So here we are, wonderful exploratory models, different materials. And then, and look at this exploratory model. This student was really out of the box. He also got some, wire mesh and tried models. He went beyond the, assignment. And I really like this exploratory model because he used wire to build the body of the spoon. See how nicely he used the wire to build the body. That is very, very interesting. And here we are, multiple models. And then that was the selected idea, and this is the final spoon prototype he built. He also built a receptacle for the spoon. So here we are, the final spoon prototype, where we have this wonderful spoon which can rest on the soup bowl and take things forward. This next topic was Ame spoon, which was spoons for the elderly, and this is also very, very interesting again, where he came up with multiple ideas. There's a combination of a spoon and a fork in this idea. And then, there is this exploratory models which he built, paper models, wire models, and, 3D foam models, clay models. And students, this is the whole process of design thinking, building models. So please get this into your habit, that as soon as you think of something, you can actually build using rough materials. And your mind will talk to it. You don't need to show it to anybody. For example, if you show this as a spoon to anybody, they'll laugh. They'll say, "Ye to diya hai, spoon kidhar hai," for example. But you know it's a spoon and you're building it. And that is the cognitive process of creativity which we are talking about. And here we have the exploratory models again. And detailing. Concept 1. Concept 2 here. Look at the handle design. And of course, concept 3. And this is the final prototype they built. The next one is very interesting. This student Naksen wanted to build a spoon which is used for Gujarati weddings, and the bridegroom's side taste the food when they come in. And that is the whole for tasting of Gujarati weddings. And then he, of course, he built all the ideas, like the same process we followed. I will go fast over here. He made clusters of the ideas. Cluster 1, he made each cluster, he has the representatives and the final concept. And cluster 2, here also you can see the different types of spoons inspired by various analogies, and you have the representative and the final concept here. And look at this wonderful flow of lines and cavities. And then, of course, we have the cluster 3, which also has the very different angular handles, and you can see how the whole sort of representative was chosen, and from the representative now we have chosen the concept 3. And what is interesting is in the representative 2, he built this as the representative, and this was actually finally selected as the concept 4, which was chosen. And he of course built all the exploratory models of all the concepts to play and interact and work with it. And it looks very exciting to see the type of variations which come because of the form. And look at this beautiful variations of concept 4, where you have the wire model, the paper model, and how the wire is bending and the paper is bending, and you'll be very happy to see how it is being used. And this is the final selected concept, and you'll be surprised to see the beautiful, you can actually wear it on your hand, you can hold it. And the best part is, you have the importance, right? You lift your hand and you're tasting. You're the bridegroom side. There's an emotion in it. There is a stance in it, and there's a personality in it. So that's the beauty of design, that if you could choose the right type of analogies and the right type of design process, you can come up with fabulous designs and take this forward. And let me show Darshan Nerkar's spoon here. If you want to work on a traveling spoon, you're on a train, and maybe it has to be compact, it has to be folded, it has to be should not shake. So multiple ideas were chosen, as we talked about in the other designs. Look at the options, students. And then how would you actually work? How would you actually use it? And there's all solid, and they're seeing as if they're using it, right, on the train. Look at that flank, students, very interesting, right? On the train, the food will not spill out, right? There's a flank at the edge of the spoon so that the food will not run away. And of course, then, you have multiple ideas and refined concepts. And here, finally, the person, his classmate is trying out these spoons, and he selected the final, spoon as this one. And finally, the final model was made a very lightweight, easy to hold. Look at the slot in the middle. Because of the slot, the holding of the spoon is very nice. And look at this wonderful, spout at the support at the back over here, so that the food is not falling away. And very nice, very different. And so there's one very interesting thing all of you must have noticed, that in all the spoons we had this fabulous sort of variation and novelty, right? Though they're so regular and mundane with all of us. So with this, we would like to, encourage all of you to look at ideas in a very different way, take in logical interpretations, build a lot of ideas, and then actually narrow down to at least 3 options. It's a must for all of you when you're working in groups, now that you've formed your groups, and then we'll take the things forward.